So today's topic, we are looking at 2.3, which is converting between fractions and decimals. Our learning goal, I can convert different forms of rational numbers. So to begin, because you can divide any integer by a non-zero integer, you can use long division. So we are going to start using some long division today. And if you don't remember, don't worry, we're going to go over that. So we can use the long division to write fractions and mixed numbers as decimals. And these decimals are rational numbers and will either repeat or terminate. And so a terminating decimal is a decimal that ends. So it stops. It does not go on forever. We can see the ending. So that would be like 1.5, maybe like negative 0.25, something like 10.824, right? All of these have an ending to them. And since we can see that there's an ending, there's no pattern, and it doesn't go on forever, that is a terminating decimal, so it terminates. A repeating decimal is a decimal that has a pattern. Oh, I don't know what happened there. Pattern. A little rough, but okay. Some examples of this would be like 1.33333, and it just keeps going on forever and ever. And the way we write that would be 1.3, and then we put a line above the 3. And so another example might be like 0.151515. And so more than one number can repeat for it to be a repeating decimal. But when we write our answer, we write it in bar notation. So it would be, oops, sorry, that's a 0. 0.15. And since the 1 and the 5 both repeat, the bar goes above both numbers. And so that little guy is called bar notation. So how do we convert a fraction to a decimal? We take our numerator and we divide it by our denominator. So let's look at a few examples. So we're going to have to do long division. The dividend, or the number on top, which is also our numerator, is what goes on the inside of our long division bar. And I'm actually going to move that and have that come down here, because I have a feeling we're going to need it to be a little bit longer. And then 11 goes on the outside. 11 goes into 5 0 times. 11 can't fit into 5. So we are going to add a decimal after the 5 and one right above the 5. So they literally line up together. And then we follow that with a 0. 11 goes into 50 4 times. 5 times would have been 55, and that's too big. So 4 times 11 is 44. We subtract 50 minus 44. We are going to borrow. So that now turns into a 4, a 1. And so we have 6. And then that's not a 0 yet. So it's not ended. Like it's not an ending. That didn't terminate. It only terminates when this turns into a 0. So that means I need to add another 0. And I'm going to bring it down. And so 11 goes into 60 5 times. 5 times 11 is 55. Subtract 55. Well, 60 minus 55 is 5. And so again, that's not a 0 yet, so we're going to add a 0, bring it down. 11 goes into 50 4 times, and now we see a pattern starting. 4 times 11 is 44. 50 minus 44 is 6. We've already seen this. This is happening here again. And so then we would have to do add a 0, bring it down, right? And so that would be a 5. So we see that 4, 5, 4, 5 going on and on and on. So now we know that we have a pattern, and so now we can write it as a decimal. So 11 or 5 divided by 11 is 0 point. And then we have our 45. We'll have the bar notation at the top. So this is what it is as a decimal. All right. So now we have 4 on the inside. And I'm going to make this longer. Divided by 33 to make it a decimal. I'm going to put a decimal after my 4 because 33 goes into 4 0 times. And so now we add a 0. So 33 goes into 40 one time. 1 times 33 is 33. I'm going to subtract these. 40 minus 33 gives me 7. I'm going to bring down my 0. 33 goes into 70 2 times. 2 times 33 is 66. When I subtract those, I get a 4. Bring that down. Now I have 40, and I've already done this one before too. We did that right up here when we had 40, and now we have 40 again. But let's just double check that we actually get a pattern. So 33 goes into 40 one time. 1 times 33 is 33. When I subtract, I get 7. And again, when I bring down this 0, now I have 70 again, in which we've already had that as well. And so we know that that'll end up going in 2 times, right? So now we have our decimal. So when we rewrite this, we need to keep our negative because we aren't changing the number, like we're not changing the number. The number, the decimal and the fraction are equal to each other. So if one is negative, the other one also has to be negative. So now I can write my decimal, and the 1 and the 2 repeated, and so the bar goes over the 1 and the 2. All right. Now we have a whole number and a fraction. So we have a mixed number happening here. And so we need to multiply. 4 times 2 is 8. And then we add the top number. So that's 4 times 2 is 8 plus 1 is 9. So we have negative 9 over 4. And so we're going to put the 9 inside. And the 4 goes on the outside. 4 goes into 9 2 times. 2 times 4 is 8. We subtract. And we get 1. It's not a 0 yet, or a pattern. So I'm going to add a decimal and a decimal on top, and then add a 0 behind it and bring it down. 4 goes into 10 2 times. 2 times 4 is 8. And when I subtract, I get 2. Still don't have a pattern yet. Bring down that 0. 4 goes into 20 5 times. 5 times 4 is 20. When I subtract, I get 0. This means I have a terminating decimal. And so my decimal equals negative 2 and 25 hundredths. Don't forget this decimal or this negative and attach that to my decimal because the decimal and the fraction are equal to each other. So if one is negative, the other has to be negative. So you're going to go ahead and do the triads on your own. And then in the next video, you will check your answers with mine.